Hi guys, welcome to chapter 1 section 3. We are looking more at how to describe quantitative data using numbers this time. Last time we were looking at graphs specifically, but today we want to look at numbers. So we're still trying to use SOCs to describe our distribution. So that means we need to look at center, shape, spread, outliers. So shape doesn't really apply here because we're not looking at the graphs. You need the graph to look at the shape. So really we're concentrating on center, spread, and outliers. So let's start with the center. This is the most basic. We have the mean and the median. So I showed you guys last time how to find everything on the calculator. Today I wanted to go a little bit more in detail with it because we want to be able to understand how the formula works, because you are provided with the formulas for everything on the formula sheet for the AP test. But the mean is something that I'm hoping you guys already know how to do, is to find the average. So you just add all the numbers together, divide by how many there are. On the formula sheet, it looks complicated, but I'm not really worried about it because I'm pretty sure you know how to find a mean. But we did talk about last time that the mean is using the symbol X with a line on top, so X bar, to stand for a sample mean. So the formula looks like we have the sum of all the X values, so all the data points. So add them all together, divide by n. So n will always stand for how many data points we actually have. X with a little subscript of I is like each data point. Okay, so pretty easy. I have an example here where we're just going to do this real quick. Here are the data for 9 different McDonald's fish and chicken sandwiches and their fat content in grams. So, real important information here. So I have it listed out here. If we added them all together and divided by 9, because there are 9 sandwiches, then we would get a sum of 179 divided by 9 gives us an average or a mean of 19.89. And keep in mind, when we talk about averages, we still want to keep the decimals there. I know you can't have 0.89 of a sandwich. Well, really you can eat some. But even when we talk about people, like 0.89 of a person or anything like that, we keep decimals for averages. Okay, next is the median. So the median, last time we just said do it in the calculator, real easy to do. But the first thing we want to do if we're doing this by hand is to put everything in order. I know this is a longer method, but I want to really make sure you guys understand how to find the median, and then consequently the Q1 and the Q3, the quartile 1, quartile 3 numbers for our 5-number summary in a data set, because we are dealing with numbers here. So first I'm going to have everything put in order in my calculator. So remember, that's the sort A function, but I'm just going to write it out here. Okay, so I've put everything in order here, and we're going to count towards the middle to get to the median. And here we have an odd number of data points, so that means the median is going to be this 19 right here. This is our median. Okay. So, not too crazy. Nothing real special here. You guys know if you have 2 numbers that end up in the middle, then you add them together, divide by 2. So take the average of those 2 numbers, and that'll become your median. And again, in the median, it is okay to have a decimal. All right, so those are our numerical ways to describe a center. We also talked about last time that the mean, because you are adding everything together and dividing by how many there are, this is non-resistant to outliers. And a median is resistant. Another word you might see, it means the same thing, is called robust. Just for funsies, why not? And so these are the different ways that we can describe a center. So that means if you have outliers in your data set, that's obvious, then you should definitely use a median to describe the center and not the mean. Otherwise, use the mean. Okay, so that's our center. So one thing I want to add when we talk about mean and median is if we were looking at both of them at the same time, depending on the shape of the distribution, we can automatically tell whether the mean is bigger or the median is bigger. So let's say we have a symmetric graph for this data set. then the mean is going to be the same number as the median. Because if you think about it, the mean should be right in the middle. As long as there's like an even number of smaller numbers, bigger numbers, then the mean should be right in the middle. The median, because we are counting towards the middle, then should also be right in the middle of the distribution because it's symmetric. So when we count towards the middle, it'll be right in the middle. So that's why the mean and the median are the same if the distribution is symmetric. Let's say it's skewed left. That means you have less of the smaller numbers, because on the left side it's shorter bars, and that means you have a lot more of numbers that are bigger because the right side has bigger or taller bars. Then the mean, because there are a few small numbers that are kind of dragging down the sum when you add everything together, the mean's actually going to be a smaller number. Whereas the median, because most of the numbers are on the bigger end, on the right side, then the median will be closer to the bigger end. So in that case, the mean is going to be smaller, less than the median. And then if it's skewed right, then it's the exact opposite. That means there's shorter bars on the right, so the bigger numbers that you don't have as many of them, but you have a bunch of small numbers, so the mean is going to get dragged towards the tail, the shorter bars, versus the median will be closer to where the taller bars are. So in that case, the median will be smaller. So I just like to think of it as the mean always goes towards the tail of the graph, the shorter bars. Mean, shorter bars. It's the same way that the direction is skewed. So skewed left, shorter bars on the left, skew right, then shorter bars are on the right, mean is towards the right, and so on. Okay, so for spread, for standard deviation, the formula looks like this. It looks kind of crazy, but really all you're doing is taking the xi, so remember that's each of your data points, subtract the mean from it, so that's x bar, and then take that amount, square it. So the reason we square is because sometimes when you subtract your data point from the mean, sometimes you get a positive number, sometimes you get a negative number. But if I square it, it will always be positive because a distance can't really be negative, and that's why we don't want to deal with negative numbers. And so if I square it, then it'll get rid of any negatives. The only thing is I need to like undo the squaring to like kind of cancel it out. So that's why at the end there's like a big square root around it. But I've written out for 3 of my data points how this formula would work. So I would take my first data point of 9, subtract my mean of 19.89. I would get like 10.89. Square it, so that'll give me my squared amount, and then do this again with the next data point and the next one. Add all of those distances up, divide it by how many data points you have minus 1. So that part's a weird part of the equation, and we get into more detail on that later, like much later. For now, I'm just going to tell you, accept this as the formula for now. If you want, feel free to like look it up online or something like that, but I'm not here to confuse you at this point in time, so I don't want to talk about it just yet. And then after that, after you divide, square root the whole thing, and from this data set we get a standard deviation of 7.04. So that means each of our data points is about 7 away from our mean of 19.89, which kind of makes sense. Like the furthest ones that we have away are like 33 and 9, and those are a good amount away from our mean of 19.89. So like on average to get 7, it's about right. And that's how you kind of want to think about it. Like, does your number make sense? Did you do something wrong? Let's check our work. So the second way to describe spread, so if we use mean to describe our center, then we're using standard deviation. If we use median to describe our center, then we need to use IQR, or the interquartile range. Interquartile just means like for the different quartiles within your data set. Quartile meaning like a quarter, right? So the first 25% of the data, the second 25% of the data, the third 25% of the data, the last 25% of the data. That's what we're really looking for here in an interquartile range. So interquartile range, we're looking for the middle 50%, because that way we kind of like leave out any outliers that might be at the very ends. We want to know exactly like in the middle about how much spread is there, right in the middle of your data. So to find that, I have my data set listed in order again because we needed that to use the median. From there, we're never going to count the median in terms of trying to find our quartile 1 and quartile 3, Q1 and Q3. So to find those numbers, I'm going to start with the 19 on the first half of the data set, and then 9, and then count towards the middle so that you get the middle of the first half of the data set, which would split it into 25% and 25% of the first half. In the middle, we have two numbers, which is the 14 and 16, so we would average those together to get Q1, which comes out to be 15. We're going to do the same thing on the second half of the data. Again, don't start with the median, so you never include the median when you're looking for Q1 and Q3. So starting with the 20 and then up until the 33, we're going to count towards the middle. So in between 22 and 27, our Q3 is going to be 24.5. So our interquartile range, when we subtract Q1 from Q3, gives us 9.5. So we're saying right in the middle of half of our data set, there is a range of 9.5, which is decent because the overall range of the whole data set was from 33 to 9. So subtracting those, you get 24. And so the middle 50%, we're really just looking at, like, you know, in case 33 or 9 was an outlier, then our middle 50% just has a smaller range of 9.5. So that kind of tells us that our numbers are kind of closer together in the middle, which is good. It seems a little bit more consistent that way. Okay. So as a recap, our standard deviation is the average distance each data point is away from the mean, and then the interquartile range would be the distance between the middle 50% of the data set. Okay, so the last thing is any outliers. So when we described SOCs, we talked about the center, the spread, shape was from looking at the graph, and then any outliers. There's a couple ways to find them. So if we're using mean to describe our data set, then to find any outliers, we're using the formula any data point over 2 standard deviations away from the mean. Or if you want to think about it as the mean plus or minus 2 times standard deviation. So this means that, like, if the standard deviation is our average distance from the mean, if there's anything really far away from that, then anything over 2 standard deviations would be like too far for us to count it as like with the rest of the data set. So I did the calculations for this one. Our mean for this data set was 19.89, and we're going to add and subtract 2 times our standard deviation, which was 7.04. When I did those calculations with both the plus version and the minus version, I ended up with 5.81 and 33.97. That means any number that's less than 5.81 in the data set, or any number that's greater than 33.97 in the dataset would be considered outliers. Our smallest number was 9, and our biggest number was 33. So both of them fall within the range that are not outliers. So 9 and 33 are not outliers. The other method is if we use the median and the IQR, then we are using the formula Q1 minus 1.5 times IQR and Q3 plus 1.5 times IQR. So again, you get 2 numbers that are going to tell you, like, any numbers less than this and any numbers greater than this would be considered your outliers. So when I did those calculations, I got 0.75 and 38.75. So again, the 9 and the 33 that we had as our smallest and biggest number in our data set don't fall in the outside of the range to be counted as outliers. So that's how you're calculating these things. Obviously, we want a fast way to calculate outliers, and so we have our handy-dandy graphing calculator for this. This doesn't always work depending on how they ask the question, but in general, if you just want to, like, really quickly check to see if there's outliers, we can use our graphing calculator. You want to have your data set entered into L1 or whatever list. So let me pull that up really quick. So here on mine, under Stat, Edit, I put all my numbers in for my data set. And then we're actually going to make a graph. So I'm going to go second stat plot, Remember the Y equals button is for graphing, stat plot because we have a list of numbers. And then we're going to turn one of our plots on. So I'm going to choose plot number 1. Make sure on is highlighted. And then we want this one right here, the one that's flashing right now. This is called a box plot. You might have learned it when you were little as a box and whisker plot because you end up with a box in the middle and whiskers on the sides. So your calculator, this one right here, actually makes 2 different box plots. The first one that's highlighted right now has little dots at the end. That's going to show us our outliers. The other one does not calculate outliers for you. It's still a box plot, it's correct, but it doesn't show outliers. So we want the one that shows outliers. Make sure L1, oh sorry, let me actually highlight the box plot that I want. And then make sure your list is used for your X list. Frequency, we're always going to leave as 1. Don't do anything there. And then you get to choose a mark. I like the squares because it's easier to see, but otherwise you can choose the plus sign or the dot or whatever. But then we want to make sure when we graph it that it fits our window. So if I hit graph right now, I was graphing something else earlier, so this isn't going to work. This doesn't show me anything. But you can kind of see like right here, it started to graph it. So of course we want zoom 9, which is the zoom stat. And there it is. And as you can see, right now I don't have any dots on the ends because we determined we don't have any outliers. If we did, then we would have dots here. Let's say, just so I can show you what it looks like if there are outliers, let's say I added a really small number of 1. Cool. So now my data set has an outlier because we said any numbers less than, oh shoot, I think it was supposed to be 0.5. Okay, let's change it to 0. So pretend we had some sandwich at McDonald's that had 0 grams of fat, which is very unlikely, but whatever. So let's say we had a data point of 0. When I do my stat plot now, I'm going to go quit, second mode to quit, and then graph. Let me do zoom 9 again because my data set changed a little bit, so it needs to like readjust its windows. Now you see a little dot right there where 0 is. And if we hit trace, the trace button right here, we can actually scroll over to it and that'll show me that is the min. It's also an outlier. And then now, not counting the outlier of 0, the next biggest number was 9, which makes sense. Okay, so when we make a box plot, let me just make sure we know how to make one. You're using your numbers from your data set of the min, the Q1, your median, Q3, and your max. This is also called the 5-number summary because these are the 5 numbers that summarize your data set very well. So, I said summarize and then wrote the wrong word. Summary. Okay. 5-number summary. Those are the 5 numbers you're going to use. And so when we make our box plot, we want to make sure that on our x-axis, we label it. So this was fat in grams of McDonald's sandwiches. Delicious. Okay, and so our, I'm going to do the box plot without the outlier. So our smallest number was a 9, and our biggest number was 33, I think. Yeah. So I'm going to go by, again, on your x-axis, you have to make sure you go by the same increment every time. So if I go by, we'll go by 5s. 14, 19, 24, 29, 34. Okay, I didn't need all that space. But our minimum was at 9, so I'm going to put a line there right above the 9. The Q1 we said was 15, so at 15 I put another line. The median was, I forgot, 19, so I put a line at 19. Q3 was 24.5, so another line at 24.5, and the maximum was 33, so right here-ish. Okay, with your 5 numbers of the 5-number summary. The middle 3 get a box drawn around it, and then the last 2 numbers, the min and the max, get the whisker. Sorry, guys. Okay. So that's how a box plot is made. So whenever you read it, you know that on the left side, that's your smallest number, the min, Q1, the median, Q3, and the max. And you don't have to label those every time, but you do have to label your x-axes, go with the same increment, and then use those 5 numbers. If you have any outliers, then the next number, either up or down from your outlier, would become the new like whisker. Okay, that's it for this section, guys. Yeah, thanks for watching. Have a great day.